How does warming affect ocean currents? Have you ever wondered how warming in the polar regions influences ocean currents? It turns out, this connection is vital for our planet's climate system. Ocean currents play a key role in regulating temperatures and distributing heat around the globe. They are primarily driven by differences in water temperature and salinity, a process known as thermohaline circulation. In polar regions, cold temperatures cause seawater to freeze into sea ice. This process leaves behind saltier, denser water that sinks and drives deep ocean currents. However, as the polar regions warm, significant changes occur that affect these currents. One major change is the melting of sea ice. As temperatures rise, more sea ice melts, adding large amounts of fresh water to the ocean's surface. Fresh water is less dense than salty seawater, which reduces the salinity and density of surface waters. For example, in the Arctic, the Beaufort Gyre has trapped nearly twice the volume of Lake Michigan in freshwater due to increased ice melt. This freshwater layer floats on top of saltier water, disrupting the normal sinking of cold, salty water that drives deep currents. Another important change is the disruption of thermohaline circulation. The reduced salinity and warmer surface waters weaken the sinking of dense water that fuels major ocean currents like the Atlantic Meridional overturning circulation. This current carries warm tropical waters northward, cools them in the North Atlantic, and returns cold water southward at depth. The warming and freshening of the North Atlantic have already led to a weakening of this circulation, which can alter climate patterns across the northern hemisphere, affecting regions like Europe and North America. In addition, the loss of sea ice in the Arctic exposes ocean surfaces to stronger winds. This causes currents like the Beaufort Gyre to spin faster and become more turbulent. While this can temporarily trap freshwater in the Arctic Ocean, it also risks sudden releases of large freshwater volumes into the Atlantic, further disrupting ocean circulation and climate. In Antarctica, warmer ocean currents flowing beneath floating ice shelves are accelerating melting. This not only contributes to rising sea levels but also adds freshwater to the surrounding ocean, potentially affecting local and global ocean circulation patterns. These changes in ocean currents are especially critical for the polar regions because they alter the balance that maintains sea ice and the cold, nutrient-rich waters that support unique ecosystems. For instance, Antarctic fish relying on antifreeze proteins to survive in freezing temperatures. As warming continues, the disruption of ocean currents threatens to change the distribution of nutrients and temperatures, impacting marine life that has adapted to stable polar conditions. In summary, warming in the polar regions affects ocean currents by melting sea ice and adding freshwater, which reduces water density and disrupts the sinking that drives global thermohaline circulation. This leads to weakening and changes in major currents, with wide-reaching consequences for climate regulation and polar ecosystems.